Good afternoon, good morning, good evening, wherever you might be in the world. I'm just checking if this works. Why must it go? Here's Ian. That's great. Ian, don't worry. I've started early. The reason there's twofold, two reasons. Reason number A, YouTube seemed to have changed the way this all works tonight, and I'm not sure it even starts. But we've got people in the comments, so maybe if you could tell us you can see us, then that would be good, and that would get rid of that one. And reason number two is we've got a fantastic thing called load shedding happening here in South Africa. Our power stations are falling apart, and that means that we are losing 7.5 hours a day of power. And our next 2.5 hours. G'day, Matthew. Welcome. Our next bit off is due to be at midnight, my time. So that's an issue.
Right on time. Well, Gary, I did talk to you about solar power a long way back.
Yeah, you're absolutely right. Matthew,
do you want me to give you a tour of my system right here, right here, so you can just remind yourself?
I have, good evening there, Phil. I've got to, I've been pricing all of this everywhere. And there's Mr. Simpson as well. Good day. I started as a little bit early. Good day, Bruce. Are you there? Over. CQ, Bruce.
He's speechless.
He is speechless. Here comes Val. For those of you joining us, guests joining us, new for the first time, there's a little at the top. There's a little mute button, and it's a good practice. We just keep Ian on mute, but it's good practice if you're not talking, just to drop onto mute. That's lovely. All right then. If we're all sitting comfortably, we shall begin. Louis never mutes this thing. Well, the guys from I forgot. Who is that doing that? From Pterodynamics. From Pterodynamics. Welcome indeed. What an interesting looking machine. And all things, I like things that once you see them, they look obvious. They're never obvious until you see it, though. And it looks like an easy way of doing something, but it can't be. It can't be at all. Would one of you like to explain how you arrived at hinging the wings to get to your VTOL solution?
Sure. I'll just do the intro. So I'm Matthew Grachik, and I'm the CEO of the company. And looks like to my right on the pictures here, this is Val Petrov, and he's the founder of the company and the inventor and our CTO. So I'll let Val go ahead and sort of explain the provenance of the design and how he came up with that. So you're on, Val. It almost looks like Val is, did we lose you, Val? Your picture went away.
I think it's over to you. I think Val's making it your responsibility.
That's okay. Well, I'll jump in. I love talking about it. So hopefully if he's disconnected, he'll come back. So, Val is a postdoc PhD, real smarty pants, born in the Soviet Union moved to the United States in 1990. He got his master's in physics in the Soviet Union, and then up there he is now back. You are, Val. So, Val, we were just going to sort of explain your background and how you ended up conceiving this idea. Really, is the focus of the question. How did you conceive of the idea of the folding wing? So you're on mute. There you are.
Yeah. Can you hear me now? Yeah. So the idea came after trying the different configurations, trying to merge a helicopter and a fixed wing into one machine, something that can fly efficiently and can also hover and near the ground in a reliable and then a quick manner. So I've been looking at the joint and how the wings can be folded and unfolded, and one day about 2 years ago it came to me, and I put a test prototype together and flew it in a nearby field, and it flew beautifully. So that's in a nutshell how this company was started.
Well, it looks absolutely well, again, so I don't mean to sound rude, but it looks obvious when you see it, but nothing cool is ever obvious and easy. So I don't mean to diss it. But how on earth does it handle? I want to know, how on earth does it handle the transitions, or is it seamless? Have you really stumbled across something that's very effective?
think it's mostly the luck that help with the transition, because all I wanted is to take this period. I haven't realized that it will be that seamless and that first moment I saw the aircraft in the air, it just transitioned and flew like there was no issues whatsoever. And this is when I realized I'm really onto something new and something that I have to pursue. So again, a little bit of luck. Now we have much better understanding of why transitions are so easy, and what the real benefit of this design and how it can be exploited. In the beginning, it was a little bit of luck.
Oh, that's very honest of you to put it like that. You must have patented this like crazy now to be bringing it out into the market, because once everyone sees it, surely they want to have a piece of this.
Yes, we have patented, and we just received an approval a month ago, actually.
Well, that's fantastic. Chris in the comments is saying there's quite a change in the center of gravity during the transition. I mean, all of us are flyers that hang around here, so I'm sure everyone's got the same questions. Bruce, have you seen it, and have you got any questions about it?
There is.
Just have to reach the mute button here. No, it looks interesting, very interesting. It overcomes one of the major problems with tilt wings, that you have a lot of forward area fronting into the airstream, so they're very difficult to handle in a windy condition. So I think it looks really interesting, and I'd have to look a bit deeper, see if I could find any fault in it. But at the moment, I can't see any real problems with it.
No, I think the idea is quite obvious until you see it put in practice. My question would be, does it only do the transition just to forward flight, or can it maintain reduced speed while mid-transition? So you don't transition immediately, you just transition halfway. Do have it fly slower?
It's a good question. Yeah, it's a good question. We have tested it, and it's flying in the mid-transition forever. So it's very stable at any stage in transition. And again, now we have calculations and the simulations to prove that is the case. Of course, when it's transitioning or when it's flying in that mid-transition, it's still partially under control of a quadcopter flight controller, so to speak. And that flight controller enables the stability of that regime. But once you have it on, and it's not very complicated controller, as you all know, it flies forever. And the best thing, it actually uses less power to fly in transition than to hover.
Yeah, that would be expected, because you get some lift from the wings, probably.
That's right.
So, but something else. The videos we've seen, you always use 4 motors, 2 on each wing. Is it a requirement, or can you go with a larger motor / and propeller and have it by helicopter?
Yeah, no, this is not a requirement. The only reason why I'm using 2, or we using 2 per wing, is just for simplicity of assembly at this stage. Yeah. You can use single rotor per wing and do it some sort of like spray modification, or you can use 8 propellers per wing. There is no real restriction in terms of number of propellers. I mean, if you use single propeller, you need to put a cyclic control on it, but that's about it.
And now a strange question: how is the life span of those hinges on the wings in terms of loading? Because I believe they have to be very robust to keep up with the forces on everything, of both the propeller from the engines and the lift.
Yeah, so we have not, again, I have not seen any failure on the prototype so far, and it was, again, very rudimentary, very simple engineering design on the hinge. The future versions that we envision right now and that we're building right now will use even more robust hinge mechanism. So I think there shouldn't be any problem with that. Really, it's just sort of an axle in a bearing, or you don't even need to have a bearing because there is not a huge speed involved in that rotation. So it could be a Bushian type of arrangement. And the articulation mechanism uses a lead screw, which again have fairly long life. It's like if you look on any retractable gear design, they all use a motor driving the lead screw with a gearbox, and that works fairly well. So I do not expect that to be a weak point in that particular aircraft.
The other question I would have, but we've seen your videos, and you can go from very little, very small to big, although we didn't see the transition on the big one.
Correct. The big one has not transitioned yet. We shifted our focus a little bit right now from making the big aircraft flying to actually building a professional version of a smaller design. And so once we're done with that, we'll go back to the big aircraft.
What kind of payload are you expecting on that professional model?
So the professional model will be the professional the production level. We'll have a 2-meter wingspan, so it will be somewhere between 4 to 5 kilo MTOW, and it will be really just to carry the camera around. And have maybe 3 hours, 2 to 3 hours flight time. So that's kind of where we're looking right now. And depending on how well that goes, we'll decide what to do next. But I'm definitely interested in making the 4-meter wingspan fly as well, and that will just have to happen a little later.
Yeah, I noticed you went from conventional VTOL to an inverted VTOL when you went from the small to the large. Were there aerodynamic or just structural reasons for that?
Say it again. I missed the question.
On the small model, you have a conventional VTOL. On the large model, it's an inverted VTOL. Was that change made for aerodynamic or structural reasons?
No, it's really, again, the reason why I decided to use VTOL is just for simplicity of construction. And the reason why it's inverted is that it will have a smaller side cross-section when it hovers. So that was the only aerodynamic consideration for the inverted VTOL. Again, there might be some issue with inverted VTOL that it gets into downwash from the propellers and from the slipstream from the wings in the forward flight. We just have to see how much vibrations the airframe will experience because of that. But I do not see a huge difference between these two configurations. So there is no really big reason besides from what, as I described, the cross-section to the side. But when you hovering into the wind, that sticking tail will catch the wind and will try to sort of weather vane into that wind.
Yeah, well, again, I don't mean to be belittle it, but it seems like you have hit on a really elegant solution. That's a better way, but it does look like a very elegant solution to what a lot of people are chucking a lot of time and investment into. So, what's the plan? Are you going to be the sole manufacturers of these things and try and produce thousands of them, or are you going to license out? What's the plan moving forward?
I would let Matthew answer that.
Or this might even be a good opportunity to introduce another person not from our company on the call. Dan Connor is our VP of Business Development. Dan, maybe you want to talk a little bit about our go-to-market strategy and operational strategy?
Absolutely, Matthew. Thank you very much. And thank you very much for getting in touch with us, by the way, Mr. Mortimer. It's a pleasure to be on the channel. So when we've got a good number of folks, a handful of folks that we're working with to license it. Some folks that are very interested in very specific markets, mostly with the U.S. government and military. and we're finding that I think that's a great start, but we don't want to get too big into licensing when we can, in the not too distant future, actually start manufacturing and selling ourselves. So we're going to be licensing out to a handful of folks, and then actually back licensing a couple of their improvements, so that as we get a good kind of team together to put the whole thing together, make sure that if there's anything that somebody else can think of to improve the product, that we're able to leverage that as well.
So you're quite early on in revealing the company and things like that, I think. Well, correct me if I'm wrong. How do you hope that the interest or the form of interest will run? Who do you expect is going to call you?
Maybe I'll handle that. So like Dan said, kind of we're focusing right now. One of our strategies with the licensing partners is to have a plurality of quality engineering teams working on this innovation and productizing the transwing, which is what we call this wing format. It's not a tilt wing or a tilt rotor or rotorcraft. It's a transwing. That's what we call it. So we have our engineering team and now these 3 licensees working on it as well. And we think that's the right size of company. Or sort of a group that's working on it. But when we look at our business out over the long haul, we kind of look at it in 3 timing segments. We've got the first 2 years 2 through 7, and 7 and beyond. So for the first 2 years, we are very much working on the licensing focus, but also working with various branches of the U.S. and allied militaries to productize the technology in all 4 branches of the military, as well as the special operations commands. But we're also working with other companies in the industrial drone space, so doing like power line and oil and gas pipeline inspection, wind farm inspection, agricultural applications for crop dusting, as well as surveying farms, as well as the same for the construction industry for large construction locations, and surface coal mining for that kind of thing to survey and inspect those. And then you've got the public safety market for police, fire, sheriff's department, emergency, kinds of response vehicles. And that's where we see our focus for the first 2 years, is in all of those areas. And then beginning in years 2 through 7, we're going to be moving heavily into the drone delivery space. And we see that as something that it's more the timing is determined by our estimate of how quickly the FAA and international regulatory bodies will be able to move to permit that kind of activity. And then starting in year 7 and beyond we'll be adding air taxis to the mix. So we're kind of staging our business in a way that we can build profitable, revenue generating businesses starting today and take us all the way through, rather than, I think a lot of companies are focusing just on the air taxi space and kind of putting all of our eggs in that basket. And we think it's important to develop the model as we go on like this, and also our business model. And I mean, having more flights and learning all from that metadata of years and years flying until we get to that point. So that's how I would lay out our business model.
Yeah, I'm a bit bewildered with the air taxi space and the idea to leap straight to manned flying. I just don't get it. I just don't understand why you do that, and why you wouldn't start with for argument's sake, a 2 kilo, a 20 kilo, and then a 200 kilo lifting platform that you've refined over time and you're quite happy with. That beats me. And now you must come to, I'm going to put a plug in for a thing that I'm very, very keen on and part of, which is the Lake Victoria Challenge. You talk about your drone delivery and happening with the FAA in a couple of years' time. Well, it's happening in Africa now, and there are contracts, not just some shiny prize. There are contracts available to the winners of the Lake Victoria Challenge, and African countries, Rwanda and others, are already using drones. So come on down in December to Tanzania and show us what you can do. But just plug it over. So I think drone delivery is going to happen in some parts of the world a lot faster, and it's not going to happen for burritos and for pizzas and for all the rest. It's going to happen for medication and useful stuff, stuff that people really need, not really have, not nice to have. Rant ends. So I see in your go on.
No, I'm glad you mentioned the Lake Victoria Challenge, because it really has the hallmark that the Transwing can go and prove themselves from top to bottom, because it's made. It's like a competition that is made for them, because
It is, yeah. Yeah, I must admit, when I saw it, that's why I wanted to talk to the guys. Oh, wow, we need that. Because that looks really cool. But I think that's probably a little bit your thought. That sounds like it's actually more appropriate for your 4-meter machine. But I know what I wanted to ask. Redundancy. So if the wings fail halfway through, so it's in a semi-hover mode, semi-slow down transition mode, do you have some form of well, we must go home now sort of operation in your coding? And also the autopilot, if you're talking to the American military, then you're going to need you must have a made in America autopilot. So I wonder if I can try and tease out of it what you're using.
So let me answer that. Currently we do not have return home capability, because this prototype that you've seen flies with probably archaic by now KK2 flight controller board. But we are transitioning to PixHawk flight controller, which will have the capability to return home and be as reliable as your average drone. It should transition automatically once it approaches the home point, and then hover and land by itself. So that is coming very soon. That is on our plan to replace the flight controller.
And
yeah, go ahead. Sorry.
Go ahead after you, whoever it was that's jumping in there.
No. Also with regard to the redundancy on the propellers, I think for big machine, probably something that is critical not to fall down on other people, we might want to put multiple motors for each propeller. So if one motor fails, which sometimes they do, the other motors will continue to spin the propeller, because with 4 propellers, obviously the redundancy of the loss of a single propeller will be problematic. And another way to solve the redundancy problem on the propellers is just to put more of them. 6 or 8 should do, and so it's also a viable solution.
And then if the wing mechanism fails halfway through?
Say it again?
If the wing mechanism fails, that's going to reduce your range quite dramatically. It wouldn't be, obviously it's not a drama because you can still land as a multi-rotor, but you'd need to be thinking, oh, hang on a minute, I haven't got the range I used to have.
That is true, yes, and I mean, yes, if the articulation mechanism fails and you're stuck in the quadcopter mode, you would have to find a place to land, and this is already in a different realm of autonomous flight navigation and fault avoidance or fault recovery, and we will be probably cooperating with other manufacturers of the AI software if they have the capability to decide where to land in case of the emergency. But that's a little bit down the road.
Sure.
Yeah, I believe that they've tackled the problem of the mechanics and the transition. All the rest is something that either Autopilot or PX4 can easily tackle with some smarts on board. That's something that is already being done on other vehicles, so it's quite easy to adjust to this vehicle. The main part on this vehicle is really the smarts on the transition and the effectiveness of the solution, which I must say again, it's so obvious that we have to have someone coming from Russia to come up with a so obvious idea. This reminds me the old story of the pencil and the $1 million pen. So
yeah, it's true. And well, I was trying to make a point because I'm trying to find some holes to pick in it, but I'm struggling because we can't just be positive. So it's just, we can't. That's not on. It's, as you say, again, I do sound rude. I don't mean to be rude, but it's so obvious when you see it. But of course, I didn't see it, so it wasn't that obvious, was it? And so it's a very elegant way of doing business, I think. So, well, fair play to you. I look forward to seeing the bigger ones. 36-foot one. I'm looking at the Paris 500 with a maximum takeoff weight of 1,700 pounds on the on your website. Does the motor sizes and everything, does efficiency really scale, or does it get super efficient when you get big? Does it get much better the bigger you go?
You do get better. You do get better because of the sort of the effect of Reynolds numbers on the big airframes. Yeah. The lift to drag ratio usually improves, not hugely, but also another efficiency increases from your propulsion system. In majority of our cases, we run electric propulsion, which does not really scale up, so to speak, much better. But if you decide to use a hybrid propulsion, which on some of our bigger vehicles we made a calculation on, the change is quite dramatic. And I don't know if you put already a hybrid version on our website yet, but it seems to be you should be able to fly up to 1,000 miles if you design a hybrid configuration where you take off mostly on electric power, but once you transition, you use a turbine that effectively coupled to generator or uses one of the motors as a generator to spin as a motor, and that's why you get the efficiency. You don't use any wasted weight, so to speak, in a hybrid configuration.
Absolutely.
Yeah, I see, for instance, that with four motors, easily two can be working as a generator, and the other two as propulsion.
You got it, exactly. Yes.
It makes sense. My question a little while ago, it does not make any sense. My question, because it makes sense to have four, because two can work as motors and two as generators. Come on, it's the easy, the simple things that make it smart. One small question: does it scale linearly with the size of the airframe? It's related to Gary's last question, but
yes. So it's a very good question. So in a regular aircraft, there are some parts that scaled as a second order of the size, and some parts which scale as a third order of the weight, right? When we're talking about the weight of different components. And so the wings, those are the parts that usually scale as a third order. And we calculated that our joint will scale effectively linear with the weight of the wing, right? So if you can make the wing, if you make a wing bigger, and by the way, in a big passenger jet aircraft, the wing only takes about 10-12% of the total weight. It just because the wing loading is so high, it flies at very high speed, right? So the proportional weight of the joint will be the same for that type of aircraft as it is for a small aircraft. That is what we see from our calculations. So there's slight changes because of this second, third law mixture of different components, but we see roughly that the weight of the joint and articulation mechanism should not really exceed 5 to 6% maybe of the MTOW of the total aircraft.
Yeah, I see that, and I assume that, for instance, if you go to do a survey, that you have to keep a low low airspeed, under 10 meters per second, for instance, for the orthophotogrammetry with the specialized cameras, you'll have to use a different wing profile. So your joint system is not affected by the wing profile.
No, the wing profile, actually, the thicker the wing profile, the better for us. right? The thicker the wing, the bigger the joint can be put inside, and that will effectively reduce the mass of the material that needs to be put in the joint. There is another trick that we can use with our design, which we do not mention yet, but I mention it right now, that we, as you have noticed, that the center of gravity of the aircraft shifts back during transition for hover, and this happens because of the weight. We have to put a significant weight in the wingtips or further down the wings. Now imagine if you put quarter of the aircraft weight in the wingtip, and let's assume just the wings for, at this point, just weight nothing, as a sake of just consideration. Then what you will have a balanced wing, because you have half of the weight in the fuselage and a quarter of the weight of the aircraft on the wingtips, and there will be no significant stress in the root of the wing anymore. So that way you can reduce the weight of the joint even further. It's effectively, you can drop it to some negligible number of the aircraft weight. But that's a little bit, talking. It's probably difficult to grasp without showing you a picture.
I was just saying, you might need to do a for dummies version for me of that. I think I understand what you're saying. Did I notice you had batteries in the wings between the motors on one of your demonstrators?
Yes, we do. Right. So that the batteries serve the purpose of moving the weight toward the wing, toward the tip of the wings. And again, because we need to reposition center of gravity with that configuration, so that the center of gravity moves from somewhere third or quarter mid-chord of the wing in the fixed forward flight, fixed wing flight, to when it hovers, the center of gravity has to move back, and this is done through the battery in the wing.
You've missed a tiny bit of a trick here. I don't know if you saw the university this week that was banging on about putting batteries in wings, and what a groundbreaking, world-beating thing it is. I've seen loads of people do that, but now I've seen yours do that as well. So you can put that in your press releases. Look, just before the university of whatever it was, we did this. Yeah, okay. I did wonder if that's what those were there for. So. And I guess you can also say then that some of the batteries are no longer in the airframe. So I guess you do have a proportion of the batteries in the airframe as well, though.
You could put the battery in the airframe as well, but presumably your airframe needs to carry some useful cargo, whether it's a people or whether it is something you need to deliver. So the weight in the fuselage is better to be allocated for that cargo, and the weight of the batteries are better, to be put in the wings. That's sort of our philosophy.
So that was exactly what this university was saying. If we take the batteries out of the fuselage and put them in the wing, then the fuselage is available for the payload. So you can use all that. You can just copy and paste everything they put in their big thesis. Just use it in yours, because you're always doing it. So fair play to you. It's very, very, very interesting, and I'm going to have to think some more about what you said about the CG. I'm going to have to sit down with a piece of paper and think about that, or maybe get Bruce with his 3D rendering machine.
Come on, Gary. I believe you'll have the transwing models at the next Lake Victoria Challenge.
So, yes, exactly. So I can see them. Yes, it's a very, very good idea. So it can, but it can't go in a what's the new acronym? There's a new acronym for I think it's ESTOL or something like that. There's, you know how this industry works. It can't do sort of a rolling takeoff. It's always going to be doing a hovering takeoff. So you have no configuration with that wing. If you have a tilt wing, if you had wheels, you could just sort of have a not quite vertical takeoff and have a rolling takeoff. But you're never going to be able to manage that, are you?
No, I don't think the rolling takeoff will be is possible. Now that you mention it, I think the one of the applications of this aircraft is that it can land and can be adapted for water landing. Because it will be stable in the water, and there is no parts that needs to be but significantly, or mechanical parts on the bottom of the aircraft, and the wings on the side will act as a sort of like a catamaran pontoons, almost to keep the aircraft in the right position in the water. So now, when it's in the water, you can imagine that the wings it can start accelerating forward with the wings slightly tilted forward. In that way, you can do some sort of a rolling takeoff, if you will.
Again, perfect for Lake Victoria. Well done. And in the comments, Paul Johnson says that just at the website says it's very innovative. Like you said, why didn't anyone think of it before? And Mac Vision 3D have to say this is the best design I've seen in this space. It looks so simple and yet so effective. Well done, guys. And again, I don't mean to belittle you, but anything, or what's it said of aviation, isn't it? You know, if it looks right, it'll probably fly right. And I think it very much applies to this. I've got to ask, how did you all meet? Do you all drink in the same pub or something?
Let me just, Gary, if I could just jump back to the innovative thing, because that's what everybody says, and it's truly true. Like, you look at it and say it seems like an obvious design, and I would just look at some of the other truly disruptive industries. You know, whether it's Airbnb, those guys didn't come from the hotel industry. Whether it's Uber, those guys didn't come from the taxi business. And, you know, Elon Musk certainly wasn't a rocket guy or a car guy at all. And I think that when you know how to solve a problem, like if I ask an aeronautical engineer how to build what we call a distance VTOL aircraft, you end up with the Bell Nexus, right? You know, you've got a sort of like half this, half that, but neither good at anything. The same thing with they're true to their history. Bell is an aircraft history, and so they built a rotorcraft with these small wings, and then Boeing did just the opposite. They built a fixed wing aircraft with short wings with these lifter props. And like, if you ask somebody with a lot of experience in solving problems, you ask them to solve a problem, they go into their brain and they say, oh, well, I know how to solve this problem, and here it is. And so by definition, you're going to get a conventional solution. Versus if you ask somebody, I mean, Val's not going to toot his own horn, but he's got a postdoc, he's a PhD in chemistry, physics, mathematics, nonlinear analytics, really. But he's been building aircraft for 42 years, since he was 8 years old, experimental aircraft. And so that's been his passion and his hobby. And he's, he sort of took the basis he had in these other sciences to apply it to this new solution and said, well, what's the most performant aircraft designed for distance flight? Well, that's a fixed wing airplane. So let's start with there and try to turn it into a VTOL. So one of the things that we didn't really talk about, which is really interesting, is in the incidence angle on the wing as it's flying through the air. Once you get to 20 degrees and approach that and certainly go beyond it, it's very dangerous, like in a tilt wing. And even though our vehicle flies all the way and the transitions from 0 to 90 degrees, when it sweeps up and back and goes along the fuselage like that, at its largest angle, the incidence angle actually only gets to 20%. It approaches 20%, and then it starts to reduce beyond 20%. And at that point where it's at 20% incidence angle, the props are delivering 70% of the lift. And that's why there's this smooth, benign transition, and you can really kind of stop it in any direction. So I just, I see that time and time in just about every industry. The real disruptive solutions don't come from veterans of that industry, but they come from people that are adjacent, that are really smart and have other foundational understandings that can apply it to a new industry. Because if you ask a veteran of an industry how to solve a problem, they're going to tell you how it's solved using conventional means, and you end up with conventional solutions. And that's not where innovation lives. So that's I would just add that.
Yeah, but what about the pub? You all from the same pub?
Okay, so I'll tell you how, just quickly. So back in summer 2017, a guy that used to work for me back in the 90s wanted to introduce me to somebody. He had grown up in Lithuania with a woman, a friend, and she's reached out and said, hey, my husband's invented this new aircraft. He wants to turn it into a product and a company, and do you know somebody who can help? And that's how I ended up getting introduced to Val back in the summer and fall of 2017. And when I saw that first video, I knew immediately how transformative that was going to be. And just reached out to Val, and we developed a relationship and worked together for many months before I came on board as CEO full-time in May of 2018. And we came out of stealth mode after we filed a patent, and we started talking with all these people who are sort of leaders in the industry in the aerospace world, and it was crazy when I would show them this video and to watch the visible fear that came across their eyes and their face as they saw it. I mean, these are people that have been trying to solve these problems for 30 years, and they just looked at me like, who the F are you? And, you know, you don't come from this industry. How did you figure this out? And of course I didn't. It was all Val. So people have the same reaction. And then we met Dan Connor through a mutual friend, also a different mutual friend. And she was kind of an advisor. Well, she was an advisor to Dan's company. And we first started working with Dan's company, Ram's Head Solutions, until we could finally convince them to come on board our company full time instead of working as a partner. And that's all sort of evolved over the last year or so.
So when can we pop into the shop and buy one off the shelf? How far out are we from that?
If you invest, you can get one soon.
That's on the $1.99 plan, is it? I think that's what we can afford in it, Bruce, something like that. Well, that's a good question. Actually, what sort of cost per unit are we looking at when you go to production?
It's going to be like any other conventional aircraft. There's nothing in our aircraft that makes it, you know, significantly more expensive. We have the same motors, the same batteries, the same flight controller, the same avionics, the same build construction, composite materials. Like we're dealing with, you know, carbon fiber composites and Kevlar and everything, like just like anyone else. So, you know, the only difference, of course, is we have the wing joints and the articulation mechanism, but that is more than offset by the weight and cost penalty or savings by not having to have conventional landing gear. So, you know, landing gear is going to be, you know, a significant cost component and complexity and also weight component. And we don't have that because we landed it very gently. The other thing I'd point out is that, you know, usually you don't want to put a lot of weight on the wingtips of a fixed wing aircraft, because when you come in for landing on a runway, when you hit the ground, those wingtips want to keep going down and smack on the ground. But we don't have that problem because the wings are folded along the fuselage during takeoff and landing. And so we can actually end up with a more elegant fixed wing configuration than even a fixed wing aircraft that uses a runway, because they can't bias the weight in the wings and especially along the wingtips. But we can, which improves the aero efficiency of the design. So that's kind of a new revelation that we've come as we've been, you know, trying to optimize the design. Now that we got the transitional component not perfected, but, you know, we understand how that works and that it does work. So we're excited about the prospects the other options that gives us.
With respect to where you can buy it, we are right now, we're going to put the PX4 source code geometry, I guess, the mixing geometry, to the public domain pretty soon. I mean, we will not prohibit anybody to build it on their own. With regard to building a version for commercial market, I think it will be probably a little bit off. I wouldn't expect anything within a year or so. Would you agree, Matthew?
Yeah, I would. I mean, I would say I'd be surprised if we didn't have a product 12 months from now that you could buy. But, you know, it might be 16 months, it might be 18 months, could be a little sooner, but we're really not in any hurry. We're trying to just do the right thing. We've spent about a year now pretty much just talking with customers and working with different designs ourselves so that we understand kind of what the market needs. And you know, frankly, the market doesn't know what it's going to need in 3 years or 5 years anyway. That's, you know, my background comes a lot from the software industry and technology fields, biodiesel and some other areas. But you don't know. You could even ask your customers what they want, and it's nobody really knows till you get it there. So Steve Jobs knew, and he's one of the few.
No, it's fascinating. Thank you very much for all agreeing to come on and chat to us. And I think we've got in early on this wave, but we'll definitely have you back when you get the production version out and things like that, and hear how it goes. And of course, I look forward to seeing you in December in Tanzania. It'd be lovely, just in time for Christmas. But I've got to rush on. Please stay with us. I've got to rush on a little bit because here in South Africa, as I said at the beginning, started a little bit earlier. We are having load shedding 7.5 hours a a day of no power, and our next power cut is due in 18 minutes. So I'd better crack on a little bit with that. So please stay with us and jump in. I just wanted to mention a couple of things. Airways Skybus's drone trials to ships with a 15-knot wind limit. Did anyone else have any ideas on that? Any thoughts on that from the floor? No thoughts. Someone's alarm. Someone is breaking into something somewhere. No thoughts on that from the floor. And then the UK, I don't know. I made a silly little video yesterday about electronic conspicuity, and blow me down with a fella if the UK CAA didn't make a call for evidence for electronic conspicuity today. And I think they want to try and pick a winner. I think this is the next big, we've spoken about this before, but I think this is kind of the next big threat to the private industry or even lower end commercial operations, is if or when a winner for electronic conspicuity, or I forgot what the Americans really want to call it, remote ID is chosen. Has anyone got any thoughts on that?
All they need to do is create a standard and then throw it open to the floor and let people build to that standard. They don't want to start picking winners. They should just say, this is the conspicuity standard. People build compliant equipment, they get certified, and there you do. So you don't have one party monopolizing the whole market.
Yeah, I can see it coming. And it was interesting on LinkedIn. I put up a provocative post, if you will, and straight away some people jumped onto it and said, "Well, here's our solution. It's great. And there's another one. Here's our solution. This is also great." And it's like, well, things already exist. We already have ADSB. We already have FLARM, Open Glide Network. We already have these things. I'm not quite sure why we need to reinvent them, unless we want to earn some cash from them. I suppose that's why we need to reinvent them.
Yeah.
Go ahead.
I was just going to say that, from we can learn a lot from the internet, the open platform for, IP traffic and routers and IP addresses, and that's a form of ID. And there are standards there, and people, as long as you adhere to the standards, there are different browsers, there are different FTP servers, there are different web servers, there are SMTP servers, and all this different stuff. And as long as we're all living within the standard, people can add value in different things. So that's what I would advocate for. The one thing we got to keep in track of too is that there's really valuable metadata associated with all of this urban air mobility, especially drone delivery. So like if you have access to that data, I can tell you on a real-time daily basis how target sales are doing well before their quarterly reports, and like if you can do that for any company, any industry. And so we want to make sure that that data is not controlled by one or few entities. So no Amazon, no Google, right? I mean, they can play in the game, but it's dangerous because they can create sort of free and open source solutions that they control and have access to exclusively to all the metadata, and that would be dangerous.
You hit the nail on the head there. That's exactly what this race is for. It's not about safety. It's not about safety for 1 second.
It's about control of the data that they don't have these days, and that is a problem. And there's some big guys on the race, some with smarter solutions than others. And I believe in the end we'll have several countries opting for different solutions, and then in the end we'll all have to migrate to a new solution that will be the sum of all the parts. So we'll get a less perfect system because we have lots of systems pushing forward on every country. So in the end we'll have to take the sum of all those systems. Even ADSB started in a crazy way and evolved what it is now.
Why would this emerging new industry be constrained, as I've ranted before, by something that was invented in the 1990s? And there's a 1990s standard. I mean, even this, I just happen to have my son's old blocky phone. This is no more than 4 or 5 years old. So just think of your smartphone in the 1990s compared to what it does now. So it beggars belief. I think we have a very short-term sort of thinking. We need to say, will this work in 2100. How will this look in 2100? And we need to be building that platform, not the old one.
Gary, the investors are worried with quarter results, not 100-year results.
I know.
So that's the problem.
Yeah, I know you're bang on right. But we've got to be careful that the industry as a whole isn't corralled into, or the sheepdogs pushing us into a pen that we don't really want to be in. Got to shout about it loud enough and ask for the best sort of a standard. And it is going to come down to, if I build a vertiport, which it's my presupposition. Now we're knocking down some trees. There's a bit of a fire risk, but I've decided I'm going to call it Vertiport Africa and think about how that might operate. And I think as an operator of Vertiport Africa, I might actually choose the systems that I want to allow into my Vertiport. But straight away, people didn't like that.
Yep. But it's like everything. You'll get one system, I'll get another one. And if we want to speak, if you want to come here over to Portugal, then you'll have to get a translation layer or some kind of crazy gadget that will do that job until the situation goes to such a chaos that some transnational organization comes up and says we all have to speak this, and this is the bare minimum of Conspiquity.
But at the end of the day, won't all aircraft in the future get out of the way of each other with nothing on the ground at all? We're building. I think we're busy building sort of ground-based solutions that won't be required. It'll all be on board the aircraft, and then therefore move wherever it goes.
Yeah, you're thinking too big, Gary. That's not the business to anyone.
Oh, yes. Okay, you're right. Yes, of course. How are we going to make money out of it? You're absolutely right. Silly old me. So it's a pleasure, MacVision 3D. And again, looks at the clock to see that he's got 11 minutes till the power goes out again. Did anyone else see anything else? You've been very quiet there, Ian. What can we attempt to? And you haven't. I don't think you've got your big coat on. So summer must have arrived in the northern hemisphere.
Yeah, I think it's actually spring tomorrow, but it's not. It's quite pleasant. There's a lot of drama at the moment, which we foresaw that there were going to be issues, but obviously with the new boundaries for the airports, and obviously a lot of us tried to fight for it for the hobbyist angle as well, just because it was so much harder to get anyone from the commercial operators to realise that there could actually be problems, because the moment you try and raise it, people shout you down and go, safety, safety, safety. And it's like, well, wait a minute. There's still practicalities around it, and has anyone thought them out, which is one of the issues we were raising. Has anyone spoken to the air traffic controllers? Has anybody worked out in this radius, how many model clubs there are and so on, which obviously they haven't, because there's a lot of kicking off now. But there are more operators again this week saying they've been denied access to fly from air traffic controllers that basically said, if we say yes, we might be accepting liability, so we're going to say no. So that drama's going on. There's, as we mentioned slightly last week, and we could probably do with that, delve into more detail, there's another consultation with MPs, or certainly those people in power that are concerned about drones again, and it could feed into more legislation. So I think people need to have their input into that. And additionally, we've got the recent figures out for the number of active operators, and it really looks like it's slowing down now. The number of active permissions went up about 69 in a quarter. Now, it used to go, even in recent times, about 100 per month. Now, some people say, well, there's consolidation, so some of these might have 20, because someone gave an example. So, but I know one of those is 20 odd pilots, but even still, it doesn't, I don't think it comes anywhere near to addressing the, because this curve, as we're seeing, it's kind of like a drop off compared historically, and looking at how many operators that are still operating, you know, a couple of years down the line, it really does look like the industry is going to get to the point where there's going to be a decline. So that's looking more obvious. And I've got back a few freedom of information requests. Yeah, it was funny. Last year we had Scotland where they said, well, we haven't got the figures yet, but it looks like we might have 6. I thought, well, that's more than everyone else has got. And they said, no, 2018, none. So they must have started those cases off and they've all been dropped. So Scotland, 0. Northern Ireland, 0. England said, well, we don't quite understand your question, even though it was the same question as last year. So I've had to go back and sort of clarify, even though the question was clear in the first place. So maybe they were just trying to stall. I don't know. But yeah, it's not looking good for 2018, just as 2017 wasn't particularly good. So again, it raises the question, why we've added all this legislation? Well, we're not prosecuting anyone. And a question actually, or it was a point your colleague Patrick had made. He says, why are we spending all these millions of pounds thinking about counter drone and all this drone ID for so few operators? If we're now saying it's looking like 5,000 could be a peak and it could start falling down from that, then how do you justify these sums of money? Which is probably a fair question to ask.
That's exactly where I wanted to take the urban air mobility thing and thinking what you'd have for a field here in Africa, and you have this, that, and the other. And the reality is, do you need it? Do you actually need it? And if detect, sense, and avoid is on board the aircraft, so the aircraft is getting out of the way even more, do you actually need it? Louis made the point, of course, we can't make as much money doing that. So, of course, we need it, because we need to make that money and we need to shout about it. So that's why we need it. Silly old me. Done it again. But yeah, we don't need it. We don't need it. But yeah, who are we? It seems like I've inherited Bruce's chief ranting act, doesn't it?
Bruce is still hurting. He's still taking care of the bruises because he has been acting as a crash test dummy. So the only thing I see, and that's why Bruce's tests were not valid, he was not dressed in orange. He has to be dressed in orange to be a valid crash test dummy.
Yeah, and my orange hat fell off. Did you see it on the ground?
Yep.
Yeah. Well, I think it stands that if enough of us, you know, if you make them up, I think we'll all fly across New Zealand and have a crack at hitting him. And I reckon we could, you know, I think it would go a lot better. We get a lot more hits in than he's deliberately missing of himself. And then before the last 5 minutes before the power goes, I have got to certainly ask Nicola. Nicola, did you find that plane yet? And if not, why not?
We had Wally. We had Wally. Now where is Wally? Now where is Nicola's plane?
Not yet. The search is still on, but I haven't been up there this past week, and might do a few flights over the next weekend. But you know, it's still snowy as hell up there, so.
That was going to be my next question. As the snow gone? What have you been flying?
At least a month or 2 out on actually the snow melting before we can start seeing some contrasty white to grey things up there.
You seem
and
to
even up there, you show up then.
Nicola, you've put your microphone at the end of a very long corridor, it seems.
They don't have beyond visual line of sight internet there.
No. I think the microphone is nearby his plane. So
it's on the one on my phone.
It's very quiet. And Chris saying in the comments is waiting for Bruce to trip over the code.
Can you hear me better now?
Yes, we can hear you better now. That's much better.
Yeah, it's the hands-free. Yeah.
So, what have you been flying, Nicola, in this last week? If you haven't been looking for that machine.
Well, the Phoenix 2400, because that is a bloody good plane. It's I don't know. I don't know if I can say it's heavy for a glider. Probably is, you know, for a pure glider. But that thing is absolutely outstanding. And with the camera mounted on the rudder, so you can see the whole thing. Oh man, it's just such a pleasure to fly. I took it as high as it would go on Sunday, and then just shut the motor and waited for it to come down. Took it longer to come down than it did to go up.
Yeah, well,
which is always
gliders are the best way of RC flying or any flying. But I'm very biased. Look, they've got one in the background. Gliders are the best, and that's that. That's
yeah, but it's got all the benefits of all my other long range rigs. You know, the same autopilot, etc., lithium ion battery pack, all the current fads, if that's still a word.
Yes. Yeah, if fad is still a fad. And Bruce, in the last 2 minutes before we lose the power, has anything caught your eye, mate?
Yes, I see that the Swiss will have to register their drones as of 2020, so that's a disease that's spreading around the world. Japan is authorizing beyond visual line of sight flights over remotely populated areas and so forth. There's a drone war competition just gone on in the Netherlands, which looks really cool. It's like battle bots, but with drones. So I'm looking to see more footage of that appearing. And one thing that should be worrying us is here in New Zealand, in the wake of the horrible atrocities that took place last week, there's been an ongoing cry for the media, the social media giants like YouTube and Facebook to stop or disallow live streaming. So even broadcasts like this may now be under threat because of the whole live streamed, shooting incident. So we've got to be a bit careful about that in the future, I think.
That's interesting. And I didn't, what to say about that. The best thing to say about what happened there is probably nothing at all. And give it no oxygen, but the condolences, obviously, to everybody. That was truly terrible. An awful event that occurred over there. And with that, on that somber note, I think I'm going to call a close to this because I see we're in the last minute. So thanks very much, everybody. See everyone again, 2100 GMT next week. Be safe, whatever you're doing this week. And, look after yourselves. We've got to go. Cheerio. Bye-bye. Bye-bye.